Yesterday, all we did our limits was graphically, essentially, and just looking at the tables. So today we're going to look at it algebraically, which I think is a bit easier sometimes, just depending on what you've got going on. So there's like a bunch of rules or like laws or whatever that you can apply to your limits. So those are all here. So essentially, you don't have to worry about most of this. Like most of the time, you don't have to worry about it. But if you're given something like the examples that we've got down here, where you just have a graph and you don't actually have the function, that's when this stuff is going to be more helpful. But it's really not too bad, I promise. So this is just saying if you've got two functions inside, so the limit of two functions added together, split it up. Take two limits. That's all that is. Same thing with subtraction. That's what this is saying. If you're multiplying, split it up again. If you're dividing, split it up. If you've got a constant times your function inside your limit, you can pull that constant out. And then if you've got like an exponent on your function, then you can pull it outside. So like find the limit and then just put that exponent on the limit. And that's basically the same thing here with your root, because you can write a root as the exponent anyway, right? So yeah, that's all that stuff is saying. Is that okay? Questions? All right, so for the first one here, we could technically break this down and say this is the limit as x approaches -2 of f of x plus 5 times the limit as x approaches -2 of g of x, and split that up into a bunch of different stuff. But I think it's a little bit unnecessary for what y'all need to do. Once you go to calculus, we'll need to do that. But right now, we don't need to. So we can just say f of, or the limit as f of x approaches -2. So f of x is the curvy one. So as x approaches -2 there, what is it? Just in general. So both sides are approaching what? 1. So that part is going to be 1. Does that make any sense? So then we're going to do 5 times the limit as x approaches -2 of g of x. So if we're looking at g, that's the straight lines. So as g approaches -2, what is it? -1. So it's really like 5 times -1 there. Are we okay with all that? So what are our questions? What do we not understand? Are we okay with getting the limits from the graph? Yes, no, maybe. Do we have questions right now? Okay, so well, let's finish this one real quick. So what is 5 times -1? -5 plus 1, -4. So your answer there, your final answer is -4. Is that all right? Okay, so then looking at number 2, we're just going to find the limit as x approaches 1 of f of x, then find the limit as x approaches 1 of g of x, multiply those two together. That's it. So if you're looking at f of x, again, that's our curve. So as x approaches 1, what is it?
1,
2. Then for g of x, as x approaches 1, what is it? It's the general limit. Is that a problem? From the left, what are we approaching? From the right, what are we approaching? If they're not the same, what do we say? D and E. So the deal with these is, if any part does not exist, the whole thing does not exist. That make sense? Or do we have questions on that? So when you're doing problems like this, if any little piece of it you get does not exist, then your whole final answer does not exist. Is that okay? All right. So for number 3, we're just going to divide our answer. So the limit as x approaches 2 of f of x. So as x approaches 2 of f of x, it's kind of in between. What do y'all think? 1.5? We're going to have 1.5 divided by... for g of x, so as x approaches 2 of g of x, what is that? 0. Can you have a 0 in the bottom of a fraction? No, so this whole thing we would say is what? What's it called when you have a 0 in the bottom? Undefined. Which for us is going to be that the limit does not exist. Alright. Questions? Alright, so the last one there, the limit as x approaches 1 of f of x. So looking at f of x as x approaches 1, what are we approaching? 2. So it's just 2 cubed, which is 8. Questions? So we're all right? Okay. So the next section is just talking about some like general rules. If it's a constant, if you're taking the limit of a constant, it doesn't matter what you're approaching, your answer is going to be that constant. So do y'all remember the one that we just talked about on the homework from last night? That it was like 2 on that piecewise function? Yeah, so I mean it's a flat line at 2, so it doesn't matter what x value you're approaching, it's always going to be that constant. So that's what this is saying. If you just have x inside there, whatever x is approaching, that's going to be your answer. And these are essentially just saying that you can plug in whatever x is approaching, plug it into your function, and that'll be our answer. So that's what we're going to do with all of these. So I think that's the easiest way to do limits. That's just me. I think some people like graphs better, but you don't always have a graph, so you've got to know like how to do it by hand. So if you do go on to calculus, part of the exam at the end is calculator inactive and part of it is active, so you've got to know how to do everything without your calculator. So like this is how you would do limits without your calculator, because if you do have your calculator, you could just graph it and then like see what it's approaching or look at the table like we did earlier. Anyway, so for this one, we've got the limit as x approaches 5 of 2x squared minus 3x plus 4. So we can basically just plug in 5. Is that okay? Everywhere there's x, plug in 5. That'll be what your limit's approaching. We don't have to worry about any holes or discontinuities or anything like that because this is just a regular polynomial, right? So as long as that's going on and you're good there, just plug and chug, okay? So we're going to do 2 times 5 squared minus 3 times 5 plus 4. So 5 squared is what?
25.
Times 2? And minus 3 times 5 plus 4. So 50 minus 15 plus 4. Is that all right? Yeah. Yeah. As long as it's just a polynomial, yeah. Yeah. So let's actually go ahead and we're going to skip 2 for right now. Are you going to skip 2 for right now?
Wow.
Well, I was going to say we can go ahead and do 3 because it's the exact same thing. So can we go ahead and do 3 real quick? So just plug in. So you're going to have 2 times 3 cubed minus 10 times 3 minus 8. So 3 cubed is what? Times 2. So we got 54 and minus 10 times 3. Oh, here you go ahead and get the 54 minus 30. So your final answer there? There we go. Is that okay?
You know they're the same one. 2 and 4?
Well, 2 and 4 are a little bit different. Why? Are they just regular polynomial functions? No, those are rational functions, right? Because there's like a fraction and you've got variables in your denominator. So you've got to make sure that whatever x is, or whatever x is approaching, if you plug that in, is it going to make your function undefined? Because if it does, then just plugging and chugging is not going to get you anywhere, right? So if we plug in a negative 2 here, would that make our denominator 0? No, so we're good. We can just go ahead and plug in. If negative 2 did make your denominator 0, then we would have to handle it in a little bit different way. So 90% of the time, if you've got a limit that looks like this, you need to try to factor it out and cancel some stuff. Because most of the time something will cancel. We don't have to worry about that on either of these, but there are some in the homework and maybe on the back side of this where we do. Yeah, on the next side we'll start doing that. So for both of these we can just plug in. So for number 2 we're plugging in negative 2. So we've got negative 2 cubed plus 2 times negative 2 squared plus 1 all over 5 minus 3 times negative 2. Is that all right? So what is negative 2 cubed?
Negative 8.
Negative 8, and then negative 2 squared times 2.
That is
And then we got a plus 1 hanging out. And then on the bottom we have 5 minus negative 3 times negative 2. So plus 6 there, 5 plus 6. So negative 8, positive 8 cancels up top. You're going to have 1 over 5 plus 6 gives you 11. So our answer there is 1 over 11. Is that right? Questions? Alrighty, so number 4, let's check that one. Make sure that it's not going to be undefined if we just plug straight in. So as x approaches negative 1, if we put a negative 1 in our denominator, would that make it 0?
No.
Nope, so we're good to go there. So we'll just do negative 1 squared plus 5 times negative 1 over negative 1 to the 4th plus 2. So negative 1 squared, what do we get? 1 and 5 times negative 1. Negative 5. Negative 1 to the 4th. 1 plus 2. So up top, what do you have? Negative 4. On the bottom, we have 3. So negative 4 over 3. Questions? So this is really not too bad, right? No response. Alright, so looking at number 5. So this time, we have a rational function again. So we need to make sure that if we plug x in, it's not going to make your denominator 0. So as x approaches 1, if we put a 1 in the denominator, what's going to happen? It's going to be 0. So that's not going to help us, right? You're just going to get undefined, which is not necessarily what we're approaching, right? So we need to try to factor and then see if anything would cancel and like simplify this fraction a little bit. So we're still going to have x minus 1 on top, but what would your denominator factor into? So will anything cancel? Your x minus 1s go away, right? So then we really just have the limit as x approaches 1 of 1 over x plus 1. So now if we plug in 1, are we going to get something undefined? No, so we can go ahead and do that. So you'll have 1 over 1 plus 1, so 1/2. Does that make any sense? Questions? Exactly, yeah. So when those factors cancel, y'all remember what happens? A whole, right? So the graph of this is probably going to be a little bit off. But y'all remember how like you would have like your curve and there'd be like a hole and then it'd keep going? So like you're coming into the same place, but there's just a hole there. So like if you just plug in 1, you're going to get that undefined hole. You've got to simplify it so that we can figure out what we're coming into on each side. Yeah? Okay. Is that all you want to say there? That'll be enough. So moving on to number 6. For this one, we're doing h approaches 0. So if we plug a 0 in, is that going to work? No, because you've got a 0 on the denominator, right? So we need to try to simplify this. So if you want to simplify that numerator, what would be a good first step? In the box, multiply out 3 plus h. When you do that, what do you get? I wrote it backwards just because it was written backwards here, but yeah. Oh, it's just got ink everywhere. So we've got a positive 9 and a negative 9 that will cancel. So you've just got 6h plus h squared all over h. Is there anything else we could do? You divide out h's, right? So 6h divided by h, what are you going to get? And h squared divided by h, what do you get? H. So this is really just the limit as h approaches 0 of 6 plus h. So now if we plug in a 0, is that going to work? Will we get undefined anywhere? Nope. So 6 plus 0 gives you 6. And that's our final answer. Questions there? All right. Are we still doing okay? Yeah? Okay, because the next one's going to be fun. So, for number 7, we're doing the limit as t approaches 0. So, if we just plug in a 0, is that going to work?
No.
Nope, because you're going to get a 0 in your denominator. So, what could we do?
Where?
We're not going to square it exactly. We're going to rationalize it. So you're going to multiply by, essentially we're doing difference of squares on the top. So we're going to multiply by square root of t squared plus 9 plus 3. So this is one of those that when you see problems like this, you're just going to recognize that that's what you need to do. It's kind of the only way to make this work. So when we multiply by your numerator, we change the second sign to a plus so that it would be difference of squares, so that we wouldn't have all those middle terms with the square root in the middle, because then that wouldn't really help us much. So when you multiply that out, we know that when you have difference of squares, it's basically just your first term squared minus your second term squared. So when you square the square root of t squared plus 9, what drops out? T squared plus 9. And then when you square the 3, we'll have a minus 9 there. Is that okay? So that's just like doing the box multiplying that stuff out. So then on the bottom, we're going to have t squared times the square root of t squared plus 9 plus 3. Questions so far? So what can we simplify or cancel out from here? The 9's cancel out on top. Anything else? The t squareds cancel out as well. So now if we plug in a 0, are we going to be undefined? Alright, so we have 1 over 0 squared plus 9. So 0 plus 9, the square root of that is going to be 3 plus 3. This whole thing is 1/6. So y'all, we did this problem yesterday with the table, right? Do you remember doing that? It was the same one from your notes. And we still got 1/6. So like, I don't know about y'all, but I was looking at it and I was like, I would have never guessed that 1/6 came from this, right? Because it was just some random fraction. Well, this is how you get that. That's right there, so. I think it's cool to see where stuff comes from, but I understand that y'all probably don't, so that's okay. Questions on that? Alrighty, so looking at number 8, we want to show that the limit as x approaches 0 of the absolute value function is in fact 0. So in order for a limit to exist, it has to be coming into the same place from the left and the right. Do you agree? So can we prove that that is happening? Yes, we sure can. So we'll say that the limit as x approaches 0 from the left of the absolute value of x is what? 0. Because that's the function that this is. So then we're going to say the limit as x approaches 0 from the right of the absolute value of x is what? Also 0. And so we can say therefore the limit as x approaches 0 of the absolute value of x is also 0. Questions on that? So if we're looking at number 9, it's essentially the same idea. We want to prove that the limit as x approaches 0 of the absolute value of x over x does not exist. So again, we need to show that for a limit to exist, left side and right side have to equal each other. So we're going to do the limit as x approaches 0 from the left of absolute value of x over x. What does that equal? -1, right? Do we see that? Yes, no, maybe? So then the limit as x approaches 0 from the right what is that? +1. And are these two things the same? No. Therefore, the limit does not exist. Questions? So I know that those two kind of seem a little silly, but once you go into calculus and like you have those free response questions, you've got to prove why stuff is or isn't true, and to support all your answers. So it's just trying to get you used to doing that. So that's why we're doing those. And then for the last one, we're given a piecewise function. You have the graph of it, but if you didn't have the graph of it, then you could still evaluate it algebraically. So we want to find the limit as x approaches 4, and since 4 is where your functions split, you can just do the limit from the left and the limit from the right, plug into each of those individually, and see that they're approaching the same number. Does that make any sense? Okay, so if we do the limit as x approaches 4 from the left, is that going to be when x is less than 4 or greater than 4?
That's that.
Less than, so we're going to use this function, yes? So if we plug a 4 in there, 2 times 4 is 8, and 8 minus 8 gives you 0. Is that okay? So when we do the limit from the right, we'll be using the other function this time. We'll be doing the square root of x minus 4. So we'll plug in a 4 again, so 4 minus 4 gives you 0, and the square root of 0 is still 0. So does the left side equal the right side? Yes, so then we could say that your general limit, and we'll say therefore, the limit as x approaches 4 of f of x is 0. And we can see exactly that that's what's happening from the graph. So, yeah. Is that all right? Questions? Anything we're not sure about, don't understand?